All right, guys, I need y'all to have your calculators out, and I want you to become calculator literate today. That is my sole goal. And some of you know how to use it, but you don't know how to tell AP the right stuff. So I'm going to show you what they want to see from you at any particular point in time. So we're going through this packet that I gave you of all the AP questions. So if you just pull up that first question, I think it's 2003, and we'll take a look at that. All right, so here is 2003. And like I mentioned also, we don't know how to do all of this yet. In a month, we will. In a month from today, it'll be around Pi Day. We will be finished with our curriculum. We will be reviewing. Because our spring break is so late, we'll start that review. We'll probably have a week and a half of review already going on. And I'll talk to you more about how I review. Essentially, what I do is one big test on all of our theorems, rules, derivative rules, integration rules, mean value theorem. I mean, all of that junk. There'll be a big test on it. And then I just start giving you a series of practice tests, like a bunch. I start out with just a multiple choice when we go through. And I grade it pretty kindly, especially early on. But the further we go, I grade it more just like AP scoring. So anyway, for whatever that's worth, and then I'll talk to you about this again, but I'll give you what we call my big test. At the end of that period, I'll give it where I have enough time to go over it. And then you'll be done in here. You'll take the AP test on that next Monday or Tuesday. I think it's maybe Monday. And but that big test is worth 300 points. And if you can make a 3 on it, you'll get anywhere from an 80 to a 88 3 times. If you can make a 4 on it, you'll make anywhere from a 90 to a 95 on it. I'm sorry, 3 times. And if you can make a 5 on it, you'll make 105 3 times. So most people, there's only like a handful of people who don't pass every year. When I say a handful, last year there were 2 people who didn't pass the big test. Sadly, 3 didn't pass the real AP test for some reason, but one, I think, just choked because she was actually pretty smart. The year before that, there was only 1 person who didn't pass it. I fully expect everybody in here to make a 3 or better on it. And probably, I think in here, we're going to have a lot of 4s and 5s. But that'll be up to you in a large part. So right here, the only thing we know how to do as of right this moment is, this is not 2003. That's 2005. Hold on. 2003. The only part we know how to do is part A. All right. So part A, here's what we're doing. Everybody with me? All right. So we need to find the area. This is a calculator problem. So AP needs to see just enough work from you to know you know what you're doing. If you are sloppy and you leave off different parts of the integral, you're not going to get credit. Okay. So here's what they would expect to see from you on this. Come on. I don't know why this is doing this today. Okay, so you're going to be taking the area from whatever that is right here to whatever that is right here. Now, I can tell that right there, that ends in 1. I do not know what that is. So I'm going to have to find the x value of that point. Now, when I do, if you want to keep using that decimal for part A, for part B, and for part C, knock yourself out. All you have to do is write out 3 decimal places, but you need to use all the decimal places. I don't like doing that. I like doing this. I'm going to call that A, and I'm going to write A equals. Now, this is part A I'm working on, but I'm going to write A equals whatever that decimal is. I'm going to have to go find it in a second. But what AP wants to see on your paper is this. You need to, if you're going to use A as a variable, you need to define it. And then you can say, okay, the area will be the integral from that A that I just defined to 1. It told me that one was 1, so I can use that. And then I need to have the top function first, the bottom function second. Can you just eyeball this and tell which one's the top function? I think you probably should be able to, because you know how to graph square root functions. You might not be as familiar with the other one. It's an exponential, a declining exponential function because of the negative exponent. but you should be able to tell that this is the root x function up top and the e to the negative 3x. Now, if you don't know that, then graph them, but we're going to have to graph them anyway. Okay, so top, start with my root x minus bottom, write e to the negative 3x. Now, I would rather not write the function out. I would rather just write f of x minus g of x, but they didn't call it f of x minus g of x. So don't you use that. Also, what you're going to see in a second, on the TI-84, you're going to be using y1 and y2 in there. You don't have to, but it's going to be easier on you to do this. You're going to be using y1 and y2 because that's how they're going to be stored. If you have an 84, you're going to do that. If you have an Inspire, all right, you're going to be using f1 of x minus f2 of x. I mean, that's what you're going to do. Here, you're going to be doing y1 minus y2. That's what your calculator is going to be using, but you need to write that. Now, in the next problem we do, they will be called f and g. When they're called f and g, you're welcome to write f and g. So that's what I would have written out, and you would get credit for this, for getting this part right. Your integrands, whatever you're actually taking the integral of, you're going to get credit for having the right upper and lower bounds, and you're going to get credit for having the right answer. That's how they're going to give you credit when you're dealing with this. So at this point, I'm going to get off of this screen, and I'm going to show you how you ought to set your calculator up to make sense of this. So I'm going to get off this screen, and let's take a look at what we would put in our calculator. So let's look at the 84 first, and then we'll go to the Inspire. So on the 84, the first thing I'm going to do is clear out whatever is currently being graphed. So I'm going to go to Y and clear all that junk out. And if I want to, I can go ahead and just set my window up and graph these. So, I can go ahead and type in my equations. So my first equation, the one that would have been on the top, was the root x. I can go ahead and type in root x. And for the second one, it was e to the negative 3x. And by the way, don't use the E button if you have an Inspire. I know it's just sitting right down there, easy to grab. Use the E function, the e to the x function. So on this one, that is right above your natural log key. So e to the minus or the negative 3x function. Now, I want my window to look like their window so it's clear to me. And this is really important, especially when you start, if you give a window that's too big, you're going to see extra roots, things like that. Their window looks like it goes from about 0 to 1, right? And it's all above the x-axis. So I'm going to go window, and I'm going to go with my minimum x. 0 is fine. I can go up to about 1, 1.2. Scale it at 1. So you can only see one tick mark. That's all I see here. And then for my y, it doesn't go below, so I can make that a 0, maybe up to 1.2. And when I graph it, my graph ought to look something like theirs. Now, I don't really care. I can't put a vertical line in there. That's x equals 1. I can't graph that. I can only graph functions. But I can visualize that there's a 1 right there. So I want to find that area. But before I can do that, I need to know that beginning bound, that lower bound. So I'm going to find the intersection there. So we should know how to do that. Second, calculate, intersect. And it's going to ask you, hey, what curves? Well, I only have 2. Is that the first curve? Yes. Is that the second curve? Yes. And when it says guess, if it only crosses in one spot, then just hit enter again. If it crosses in multiple spots, then get your cursor close so it knows which one you want. But there's only one place, so I'm going to hit enter, and it gives me that intersection value. Now, before you just write it down, and you're fine on your paper where you had A, go ahead and write 0.23873 or whatever. You only need to put 3 decimal places, but you need to be exact when you integrate so your area is exact. So let me show you how to do that. Now, the 84 has a feature in it, which is kind of nice, in that when you solve, it automatically stores that as x. Like watch, remember 0.2387. So I'm going to quit, and look, if I hit x equals 0.2387. Now, the Inspire doesn't do that, but it stores it. But I want to go ahead and store this as A, so as I reuse this value in all the other parts A, B, and C, which I'm not going to do here, but you're going to be doing that in a month. you're going to be reusing this A value over and over again. So to store that, all you do is go store, like I could hit X again if I want, and your store button is down there on the bottom left. Store it, and I'm going to just store it as A. So now that value has a unique A, and if I were to go and find another intersection, I haven't lost this one, okay? Now the Inspire works a little differently. I think it's a little bit better, but that little feature about that instant store is kind of nice on an 84. So now I have it stored. So all I have to do to find my integral now that I have that stored as my A is to go math 9. I'm going from A, which is alpha A, up to 1. And what was my first function? Now listen, on this one, how hard is it to write root x? It's not hard. But you're going to see on some of these subsequent problems we do today, sometimes the function is like 20 button pushes to type it in there. And it's really easy to get that incorrect. So I don't want to keep retyping it in there. Since it's already stored as my y1, why don't I just go vars? Remember where vars is? Right there between, see, right by clear. Vars, y vars, function y1, and it pops my y1 on the screen. And then that's my top, and then minus vars, y vars, function y2 on the screen. And then just fill in the x, and there's my area. And AP lets you round or truncate. Round means you'd write 0.443. Truncate means you just go to the third decimal and erase everything else. So they would take 0.442 or 0.443. But you cannot write that as your answer on the AP test. You can't go y1 and y2. You can't go f1x and f2x. You would have to have the actual equation and the actual equation in there like we wrote, unless they define it as f and g, in which case you have the option of either putting the equations or putting f and g. But you do not have the option here. We're going to use our calculator this way, but we have to actually put the equations in like I had on my paper earlier. The what? The A? Oh, it's the alpha. You see that you have letters. You have the A and the B and the C. So all I got to do is do alpha and then hit that, and it grabs the letters. All right. What else was I going to show you? That's probably good for now. Okay, so for the let me just show you one other thing. Back to the graph. Let me see if I even know how to do this. Okay, so back to the graph. Watch if I go second calculate. What do you see at the bottom there? Integral? If I said integral 7, actually, you know what? It doesn't let me do this. No, it could actually let me do an integral of one function, but it doesn't let me do the integral of 2. Never mind. Forget that. All right, look at the Inspire. So the Inspire is going to be a little bit different. Once again, I'm going to go to my graph. I'm going to delete all the junk that I have in there. And I'm going to go to my to my tab, and I'll fix my window in a second. I'm going to hit tab. My first function was square root of x. I'm going to get it in there. My second function was e to the negative 3x. I'm going to hit tab. The e function, not the e variable, but the e function negative 3x. I'm going to graph that. And honestly, this is probably good enough on this case. I really didn't need all of that, but I can see my image in there pretty well. So if you want to change your window, knock yourself out if it looked like this. But look, if I had this as my window, you can see it's not a bad thing to have that as your window. But to me, it's more confusing for people to not see something good. Are y'all with me? Menu, window. I'm going to go settings. Min is 0. I'm going to go tab. I really only need it out to about 1 or 1.2. Scale it at 1. Y is 0. I don't know, 1, 1.2. Auto at 1. I mean, scale it at 1. And then when I graph this thing, it looks better to me. And the better your window resembles what they have, I think the less trouble you're going to have finding what you need. Now, I still need to find that intersection with the Inspire. So here, everything runs through that menu. I'm going to go menu, analyze the graph. Intersection is 4. It's a little bit easier when you just click lower bound, upper bound. Now it gives you the point like the other one did, but it's not going to store that as an X. But it makes it really easy to store that as anything you want and store that by just clicking on those. So if I want to store the X part, I just get over it, click on it to highlight it, and then I'm going to go to store, which is right above the var. So control var, and it goes, what do you want to store it as? I'm just going to hit the letter A and hit enter. And if I do it correctly, you'll see it highlighted. Highlighted means that's been stored as a value. And sometimes you'll see starting tomorrow, we're going to be doing some right minus left areas without, they're not going to be functions. And we're going to need the Y value there. But right now we don't need that Y value. So I'm not going to bother storing it. But that's stored as A. So now all I have to do to graph this is I go to the book button, the left side of the book button. If you click on it, there is your integral. Pull up your integral. And again, I've stored it as A. So A to 1. And this time, I don't do Y1 minus Y2. I do F1 minus F2. So I'm going to go back to my vars button. It's just a little bit easier to find here. I click vars. There's my F1. Now make sure the F1 is the one on top, but it is. The only difference is here I got to put an X in there. So I fill it in with an X. And then minus vars, go down and grab F2. Fill that in with an X. And when you put the DX in there and hit enter, 0.442 or 0.443 would be accepted. But if you're going to use A, you have to write out what A is. If you just, in your problems, have an A right there and you never state what A is, you're not getting that point for finding that A value. Y'all with me on that? So just to kind of verify, let me just see. AP has this. You can go look at it. So scoring guidelines. So for this problem number 1, you got 1 point for your integrand, which means 1 point for writing this right here. See that? 1 point for your answer. And then you got another 1 point up here. You can see for having the correct limits. So from T to 1. But because they were the same in part A and part B, and I think part C, T to 1, they stored it as T instead of as A. But whatever. If you store it, you get an extra point there. So this was a 3-point problem you could have. And guys, if you get 3 points off each of these free responses, you're well on your way to passing. Because most people do a little bit better than that. You really want to make your goal about 4 to 5. If you can get 4 to 5 out of 9, now you're looking at a 4. Most people in my class would get all of these points because we spend way more time than we normally do on this. So most people are 7 to 9 points. We probably average 7 or 8 points on these area volume questions, typically every year. Are we good? So again, notice how they stored it. They stored the whole point. I mean, notice how they wrote, hey, the point TS is that. If you didn't need S, then just say T is 0.238734. Write that down, and then you can just reuse T over and over. And by the way, these are just examples right here where they list the questions real quickly. That's not the way they write it on the AP test. And when you start doing practice tests, you'll see that. They'll have question A, and then they'll have this big box. And your answer just goes in the box. And then they'll have question B and another big box. And your answer will go in the box. So that's how they do it here. They're just trying to save a little time. All right, let's look at that next one. It's 2004. So 2004, free response number 2. All right. So this is number 2. And notice this time the equations are a little uglier for you, but notice they named them F and G. So this is a calculator problem. You do not have to show your work. Your calculator is going to do all this, but you have to show your setup, your upper and lower bounds, all of that. Now, this time they made it really easy on you, and that you didn't even have to find the lower bound or the upper bound. It was 0 and 1. You don't always assume if it looks like it is, it's 0 and 1, but it's really easy to check that. If you plug a 0 in there and there, you get 0. You plug a 1 in there or there, you also get 0. So it's pretty clear that those are the upper lower bounds. So this is what AP would expect to see from you. Come on. All right, so they expect on part A right here to see you define, you don't have to define anything as A and B. So they expect to see the integral from 0 to 1. Your top function is f of x, and you are welcome to use that name that they gave it. And your bottom function is g of x. You're welcome to use that name. Put that whole thing in parentheses, d of x. So you're probably only getting a point for that setup and probably a point for your answer, but we can check in a second. So you really have done a lot of what you need to do already. Here's back to the 84. So on the 84, I need to go in there and regraph these. So I'm going to clear out my equations. And I'm going to make my f function like I did before, the y1. So 2x parentheses 1 minus x. And the other one is 3 parentheses x minus 1 parentheses root x. And my window probably needs to change a little bit. So I'm going to go to window, and on my x looks fine, 0 to about 1.2, but my y min goes down. So I'm going to go down to about 1.2, up to about 1.2. Let's just see what happens. Again, as long as you can see pretty much what the graph looks like and not a whole lot extra, and I can do that here, I feel pretty good about this. All right, so I have it in there. I don't even need to find the intersection points because I can see that they're at 0 and 1. So all I have to do is go back to my screen. Heck, if you're doing this work, I've already got it set up as y1 minus y2. Just I can go back and grab that and just change that a to a 0. And that would be my integral from y1 to y2. And it will use the new y1 and the new y2 values and give me the, this one's going to have to think for a second, but 1.133. And remember, you got to round to 3 decimals. Don't put 0.3 repeating, which it probably is, even though it's not doing that on this calculator. The Inspire sometimes and the 84 a lot give you really crappy answers towards the end of these area problems. But if you're rounding, it never matters. All right. And then if I have the Inspire, once again, the only difference would be I delete all that junk out. Probably change my window, make that y value go down to maybe negative 1.2. And then tab, I need my 3 parentheses x minus 1 root x. And if you ever get a weird symbol when you're typing these in, just put times in between there. Sometimes the Inspire does weird stuff. Wait a minute, why did I do G first? Okay, forget that. I'm going to go back up and delete that. I kind of like F first. So 2x parentheses 1 minus x. And then for my, okay, I guess I do need to put a times in there. See how it gave me a weird symbol? There's that. And then for hit tab, and then with the 3 parentheses x minus 1 and root x. And if my graph looks good, I feel pretty good about it. Remember, that's your y1, that's on top, that's your y2. So I'm going to go back. And if I wanted to, look, I could just come back up and grab my integrals. Make sure you know how to do them, and make sure the F1 is on top, the F2 is on the bottom, but I need to get rid of that A. So I'm just going to come over there and delete that and put the 0 in there. And this one's probably a little bit more accurate. Yeah, you can see the 84 doesn't get messed up at the end there. I'm sorry, the Inspire is very accurate, but sometimes the 84 is off. But if you're rounding to 3, it won't matter. You seeing this? Not too bad. All right, what about this next one, 2005? All right, so 2005 would have been great for you guys right now because you would have gotten close to 6 points, if not 6 points, just from area questions. if you got it right, which I would assume you'd probably would on this. So this is your 2005. Now, the two questions were find the area of R, find the area of S. So somebody tell me, what would I write? What would I write right here? What would I write for the area of R? This would be problem A. The integral from what to what?
0.
So I definitely know the left side is a 0. So that part's right. The right side would be what, though? I don't know that yet, do I? So when I would have to find that, I'd probably call it A and just say A equals, and I would write that value down. And then from there on out, I would just be able to go use A for each one of my area problems. Now, what's on the top? Do y'all see that? Now, on the S function, F is on top. But if you follow F, it's definitely on the bottom of R. And if you follow G, G is definitely on the top of R. So I'm going to have G, and I'm totally fine on using G of X and F of X because they named them G of X and F of X. So if I wrote the correct A value and I wrote it out like that, that would be 2 points. And then whatever I get for an answer would give me the rest. But you got to write out what A is. And I don't know what it is, about 0.2 or 0.1 or 0.3, something like that. So let's go ahead and get this in our calculator, see what we can do. Now, I can't really tell at first glance right here where this looks like the one right here is the sine function. I really don't know where they intersect. I don't. I mean, I can think about what sine does here, but I really don't care. I'm just going to graph it and make my window kind of look like it. So here we go. Let's just say I had a really crappy window here. I'm going to go to my graph screen. I'm going to delete all that junk out. And let's just say I was on a regular standard window that looked like this right here. So if I had that right now, let me just tell you what I would do to get somewhere on this. I'd say, you know what, let me just go ahead and graph these and see what happens. So my first one, doesn't matter whether you call it F or G, I'm going to let F be first. So 1/4, if you want to use a fraction button, great, plus sine, if you're ever going to use a trig function, and really in AP calculus in general, what mode do you have to be in? Radians. And you can see at the top of my screen, it says degrees. That's my scratch pad, but I'm going to change everything to radians. So I have pi x. So I'm going to put a pi in there and an x in there. That's my first function. You can see it looks terrible right here because I'm in the wrong mode. So I'm going to change my settings to menu settings to radians. And when I do that, it's going to graph it like a sine function, like it should. And it clearly, that does not look like my screen, does it? I mean, the problem that they gave us the picture. But I'm going to hold off. My other one is 4 to the negative x. So 4 raised to the negative x power. So this is way off. I'm going to start playing with my window now. So what my window look like? Well, definitely I don't go anywhere left of 0 or below 0. So I'm going to go to Window, Settings. I'm going to let my min x be 0. I'm going to let my min y be 0 and take another look at it. And now when I look at it, I'm like, oh, I'm way, way too high. So I really only need, looks like maybe to go, if I'm up 6, maybe I need to go up to 1 or 2. So I'm going to go back to Window, maybe make my window go up. I'm going to go down there, maybe only go up to like 1.5 or 2. And then I'm going to go max. I don't know. Let me change my max to like 3 and see what happens. Okay, that's looking better, but still too much. Let me change my window. Let me change my max to maybe like 1.5 and see what happens. Okay, much better. So I'm just playing with it. But now that I have something that looks good, I can see where it intersects right there. I need to find both of those, don't I? Right? Eventually. Now for this first area, I only need to find that first one. For the second area, I got to find both. So on the 84, here's where you got to be careful. On the 84, when I find that first intersection, it automatically stores it as X. What happens if I then go over here and find the second intersection? Stores over it. So make sure when you find the first one that you go back to your screen, store that as an A. And then when you find your second one, store that as like a B. But the advantage of the Inspire is you can go menu, analyze, intersection. Look, I can just go left bound, right bound. I can go right up to that X, click on it, store it as A. And then I can do the same thing. As you can see, it's stored as A. Menu, analyze, intersection, left bound, right bound. I can store that as a B. Now, it's just 1.0. So the fact that it's 1.0, I really don't know that I would store it as a B because it's 1, right? So why would you bother? But if you wanted to, you totally could. So what am I writing on my paper? So right here, if I was doing this on my paper, what I would have right here is I would have the integral for this first one. What's on top here? That's the g of x. So because remember, it's swooping down right here. F there, g there. But I would have g of x minus f of x for the first part, a. This is this region right here. From 0 to my a value, but I would have to write a is 0.17822. I would have to write that down, close my parentheses, and then I'm going to type that in my calculator second and get that area. For the second part, for part B, which is this region, I'm going to have to go the integral from A, which was the first part, to B, which is the second part, which means I also need to have B written down, which is just 1. But again, if it's a simple number like 1, just put a 1 there. But on this one, it would be f of x minus g of x dx. Right? But again, if you know it's 1, just use 1 instead of B and you don't have to bother. So what do I get for that first area? So for the first area right there, I am going I'm going g minus f, so f of 2. Let me clear this out. So my first area, this is what I would do. I would be doing, do I have an f of 2 up here? Nope. So for my first one, I'd be going integral from 0 to a, but I would be doing the second function, so var f2 minus var f1, and fill in the x's for all 3 spots. Bam. And I think that's right. Nope. 0 to a. Oh, I'm in the wrong mode. Radians. Make a difference. 0.064. Or rounded to 0.065. So that's what I would do in my calculator. But remember, that's different from what I would write on my paper. And then for the next one, I'm going to go integral right here. But this time I'm going from A to 1 or A to B. And this time I would have to do F1 first minus F2 second. And that should give me 0.410. Y'all seeing that? Are y'all good at with 84s? Okay. And another thing, I don't know if I mentioned this, but when you're storing on an 84, like for instance, you already got something stored as X, right? Like say my X was 1.2 right there. And every time I do it, I'm gonna get 1.2. You can do one of two things. You can either get that 1.2 on the screen like this, and then just go store, and it'll go, oh, I'm storing the answer as A. You can do that, or you could just say, and then from here on out, every time you pull up the A, it's 1.2. Or you can just say, hey, X, store A. That works also, right? So if you feel more comfortable seeing the number and then storing it as A, great. but be able to store those as A's and B's. You're going to do that a lot, especially, and you might not think it's a big deal here, but once you're having to do part A, part B, and part C, and use that stuff over and over and over and over, do it. Sometimes I do it when I don't even need to graph, just because I like having the functions in there. I like being able to pull up my F1 and my F2 or my Y1 and my Y2 without having to retype it in my calculator. Just makes your life easier in the long run. So anyway, what about, yeah, this is just not hard. All right, how about this? Look at that 2005 Form B. So 2005 Form B would be this one. And just do it. This is problem number 1. Looks like that. Go ahead and do it. And then tell me what you get. And tell me what you write. Did y'all get this? So if you've got that, you have that set up and you have A written down, or your other option is you don't write A down, but you actually put 0.0, what was it? 1356 or whatever. You could write A in there, or your other option, you could literally have that written in there and that written in there. You're welcome to do that, but you will run into some problems sometimes where, because that's not a big deal to type in there and to type in there. So if you still have to find out where they cross, which is important. Sometimes you won't even have to do that. You could say, forget this, I'm not even graphing it. But the fact that I got to find area here, and then you're going to have to do a solid, revolve a solid, then you're going to have to do cross-sectional volumes, which that's actually going to be on this test. the fact that you got to do all these three things over and over again, it really is helpful to have them in there as functions, use them. But again, that's not what I would have typed in my calculator. It would have been F1, G1, or Y1, Y2. Can't use that when you communicate to AP. You can do this rounded or truncated to 3 if you want. But when you type it in your calculator, this needs to be exact in your calculator. Like, I don't know. Let's just see. If I actually typed in, instead of exact, if I just put in 0.136, oh, it's 1.13? Okay. So if I put, let's say that area was way off. If I put 1.13, let's see if it's much off. I get still 0.429. Actually, I get 0.4291, which may be a little bit different, but it wouldn't have affected my rounding. So if I had only used that or that rounded, I would have still been okay, but that's not always the case. Sometimes when you have bigger volumes, that might move a little bit. And if it moves, then you just lose that point. So I'm always storing and being exact whenever possible. But yes, you don't have in your calculator to be exact, but you don't have to write it. You can always round to 3 in what you write on your page. We good? All right. I didn't want to do much more except to really make you feel good about your calculator. You've got a couple problems on the homework. I think it's going to be wise if you do them just to kind of make sure you're in a good place. But if you're good with calculator, tomorrow we're going to change things. We're not going to have functions. We're going to have different kind of equations, and you're going to have to think creatively about your area going right minus left instead of just top minus bottom. So that'll be a little bit new. All right.